So video 3 is going to be more like video 1 in that we're looking at some of these trig equations. These are going to be a little more complicated. The process is a little bit more involved, so they'll take a little longer. We'll look at 3 of these, and that's it for this video. So what we see here, examples from video 1 look like the following. So 9 sine x minus 5 equals 3, things like that. Examples from this video are going to look like these in purple down here. The difference is what I want to point out to you right now. What we're taking the sine of, or the secant of, or the cosine of, and so forth. So these things in video 1, all you've seen so far is just an x, so that hasn't really changed much. When we have a 2x or a 3x or an x over 2 or anything besides x, we need to go a couple steps further in order to solve. Okay, so here's our first example. Make sure you watch closely. There are a lot of different steps to this, but once you get this down, hopefully it won't be too bad. So the first thing I want to point out is that this is a 2x. So what I'm going to do with that, I look at my original domain. I'm going to move it up here. Instead of an x, we're going to write a 2x in there. Since we multiplied the middle piece by x, just like any regular equation, we need to multiply all 3 of these parts, so the 0, the x, and the 360 by 2. So instead of 0 to 360 with an x in the middle, we're going to get 0 is less than or equal to 2x, which is less than or equal to 720 degrees. We'll come back to that in a little bit of what that's going to do to our problem. So there's step 1. Step 2 is to solve kind of like you normally would. So we get cosine of 2x equals 7 over 12. You want to leave this 2x like this. We're going to take care of it at the very end, which means your next step is to take the cosine inverse of 7 over 12. And then just remember that that is going to equal 2x now, so we'll have to divide out a 2 at the end. When you plug that into your calculator, the value you get is 54.3 degrees. So let's take a look up here at the unit circle if we can kind of take a little side note. We took the cosine here of a positive number, which means we're going to have answers in quadrants 1 and 4. So 54 degrees, we'll call that here. This doesn't have to be perfect. The corresponding angle in quadrant 4, we'll call it there. Since we're going to 720, this is where things start to change. So instead of 0 to 360, I start at 0. I need to go all the way around to 360 and then back around to 720. So I need to do 2 full circles. My question for you is, how many solutions does this have? We are going to end up with 4 here, and here's how you can tell. As we did this, we started at 0. We hit an answer here. We kept coming around, hit another answer. And as we go around, we ended up hitting these rays 4 times. What you will notice, we'll talk about this in a minute, these answers and these answers are on the same ray, meaning they're coterminal, so they will be pretty easy to find once we get there. So we know for starters that we have, make sure the colors are right here. That's an equal sign. So 54.3 degrees equals 2x. Well, what else equals 2x? We know that to get an angle in the 4th quadrant, we need to subtract, so 360 minus 54.3. So we're also going to get that 305.7 equals 2x. So that covers 2 of our answers. So that one's all set. That one's all set. My question is, how do I get from this answer to this answer? Well, all I did was do 1 more circle. So I can just take 54.3 and add 360. And we're also going to get that 414.3 equals 2x. And then lastly, I need to get from this answer, which was our 305.7, if I add 360 to that, I get 665.7 equals 2x. So here's your starting point. Now the last thing is we obviously want these answers in terms of x, so all you have to do from this point is to divide these by 2. And I'll save you the suspense of what those answers are. Again, all I did was took these 4 numbers, divided them each by 2, and I get my final answer for this problem, or final answers, there are 4 total, to be these 4 numbers in here. So again, long problems, not much more complicated than what we've already done. They're just a little bit more tedious. So let's take a look at yet another one. This next one up here says no calculator, which may worry you. That just means that we can do it on the unit circle. Slide this, we may need some space. You'll notice here we're also in radians. We have 0 is less than or equal to x, which is less than 2 pi. So let's take a look. We have a 3x in here. So the first thing I want to do is adjust my domain, and I'll throw that up here. The 3x needs to go in the middle. When we multiply 0 by 3, we're still going to get that. On the right side here, we're going to end up with 6 pi. So what that means is as we go around in this circle, we need to go around once, twice, and 3 full times to get back to where we need to go. So that 6 pi is reflected right here. We'll take a look at what that's going to mean for solutions in a second. So if we solve this, and again, we don't have a calculator, so I would say that the cosecant of 3x equals -2. Again, we don't have a cosecant inverse button, so we can also say that the sine of 3x, the 3 does not affect this part of the problem, you can throw that in parentheses if that's easier for you to see, equals -1/2. So -1/2, we know that 3x, the reference angle for sine being -1/2 is 30, or sine being 1/2 is 30, sorry. Sine is negative in quadrants 3 and 4, so this is the area that we want to look at. So the angles in quadrants 3 and 4 with a reference angle, and we're in radians, so it has to be pi over 6, is going to be 7 pi over 6 and 11 pi over 6. So there are our first two answers. We know they have to be 30-degree reference angles, so if I draw these out, we take a look at how many solutions we're going to get. Try these dots again. As we go around the circle, we hit 1 here, 2 here, 3 here, 4 here, 5 here, and 6 here. So we're actually going to end up with 6 answers. But again, the good news, half of them lie on one line and half of them lie on the other. So at this point, all I really need to do is add 2 pi, because that's how long it takes me to get from this solution all the way around to this solution. Since our reference angle is pi over 6, we're going to be adding 12 pi over 6. So if I take 7 pi over 6 and add 12 pi over 6, I get, sorry, I'll make this thinner, I get 19 pi over 6. Since we need to go around again, if I add another 12 pi over 6, we get 31 pi over 6. So that took care of all of these. So this is quadrant 3 is all in here. 7 pi over 6, 19 pi over 6, and 31 pi over 6. We need to do the same thing in the fourth quadrant. So with the 11 pi over 6 as the first angle, we're going to end up with 23 pi over 6 and 35 pi over 6. So not bad. Those are our 6 answers. Again, we need to remember this is set equal to 3x. So we need to divide all of those by 3. Again, I'll save you the suspense on that too. So here are your 6 answers in blue. Again, I just took all of these and divided them by 3 or multiplied them by 1/3. All that did was change the denominators from 6's to 18's. And those are my final 6 answers for that problem. Alright, last one. Believe it or not, this one is shorter. So we see in here that our x over 2 is what's going to affect our domain. So when I take my domain and I write x over 2 here, it again is not going to affect the 0 degrees. But on the right side, since we're dividing x by 2, we're only going to go to 180. Which means when I'm looking at my solutions, I'm only focused on quadrants 1 and 2. Since we're only going from 0 to 180. That's our entire track. So again, we'll solve the same way. We'll say that the secant, x over 2 we'll leave alone till the end, equals 7 over 3. That means that the cosine of x over 2 equals 3 over 7. When I take the inverse cosine of 3 over 7, I'm going to end up with x over 2 equals 64.6 degrees. The next thing I would usually ask myself is, well, I took the cosine inverse of a positive. In what quadrants is cosine positive? Well, that's usually 1 and 4. But in this case, it's only going to be quadrant 1 because we don't even get to quadrant 4 because we stop at 180. So that's it. This is your one solution. The final step in solving for x is just to multiply by 2. So we end up with here 129.2 degrees, and that is your one answer. So again, that's obviously a lot shorter than the last 2 examples. I know these are long and a little bit complicated, but as you get some practice, you'll get better at them, and hopefully they'll come pretty easily to you.